All right, so last time we were checking out hypothesis testing, and in an effort to kind of help you understand the big picture, I did gloss over a couple things. Part of doing a successful hypothesis test is checking conditions. Get used to this. We're going to check conditions a whole lot for the rest of the year. So the conditions that we're really interested in is, hopefully these look kind of familiar. Data should come from a random sample, so we're going to be looking for that. N, remember that's my sample size. My sample size needs to be less than 10% of the total population. And NP needs to be greater than or equal to 10, and also NQ. Please note that when we're doing confidence intervals, we did NP hat greater than 10 and NQ hat. But in Chapter 20, it's just regular P and Q, no hats. Okay, that's just technicality we really need to watch out for. All right, so just to refresh your memory, here was the story problem we were working through. And I'm going to go ahead and check the conditions for this story problem. So the first condition that I'm going to be investigating is random. Do I have a random sample? Well, it says right here in the story problem, these homes are randomly selected. So I'm just going to note that it says so in the problem. Awesome. All right, the next condition I was checking, I need to verify that N is less than 10% of the population. Okay, so remember, N is my sample size. There's two numbers up here. I have a 376 and a 400. Well, 376 had smoke detectors, but I visited a total of 400 homes. So 400 is my sample size. And less than 10% of the population. Well, the population would be, let's see, I visited 400 homes. So the population then would be all the homes in the city. Now I'm going to take just a minute. I wrote the statement, but I want to make sure it makes sense in my brain. For 400 to be less than 10% of all the homes, that would mean there needs to be 4,000 homes in a city. That actually seems pretty reasonable to me, especially if it's a large city. So I think we're going to be okay there. All right, and then last but not least, give myself just a little bit more space. I need to check to see that NP is greater than or equal to 10, and NQ is greater than or equal to 10. All right, so N, remember, was my sample size. P. Well, remember, I'm not using P hat, which was the 0.94. That's not what we're using. We're using the null hypothesis. Remember, we believe that the proportion of homes with smoke detectors is 90%. So this is the P that we're going to use to check our condition. So 0.9. Let's see, if I plug that in my calculator, I get 360. That is definitely bigger than 10. I'm good to go. And then that means N times Q would be 0.1. That's going to be 40. That's also bigger than or equal to 10. So I'm good to go, and we do what's called a one proportion z-test. All right, so I'm going to leave you with just one more thought for today. Two more thoughts. So this is how it will go when we do a full and complete hypothesis test. The first thing we do is write the hypotheses. Remember, there's a HO, that's the null hypothesis, as well as an alternative hypothesis. The second thing we will do is check the conditions. That's what we just practiced. The third thing we will do is explore the mechanics or the model. Okay, this is where we find a p-value. Remember last time we constructed the normal model and we looked for the chance of getting that 0.94 or even higher. And then the last thing we'll do, step 4, is write a conclusion, and it does have to be in context, meaning we refer back to the story problem. All right, and again, we'll practice all these things together. All right, so the second thing I said I was going to leave you with two thoughts. TwoTails. TwoTails. This is weird that I call it this. In case I haven't mentioned before, when we're dealing with a normal model and I shade something that goes forever, Most people call that a tail. I don't know, like the tail of a cat. So the last time we did a problem, we were looking at just one tail. There are circumstances where we're going to look at two tails, right? Like I have both ends shaded. So our story problem said we were looking for, right, above 90%, so that's why I shaded the side that was above. But what if our story problem had said this? Okay. It didn't. We're just pretending. The city wonders if this effort has changed the local level from the 90% national rate. So now I'm interested if it's gone up, or maybe people got so annoyed with our TV campaigns that they threw out their smoke detectors. So I'm just as interested if it went down. Okay? That's what I'm saying here. We'd be interested if the proportion was lower or higher, either way. So what that looks like when we're calculating that p-value or that probability, okay, remember we observed 0.94, so I'd stick that on my picture. Shade up, and we calculated this at 0.0038. But now I'm equally interested, what if it had gone down? So I'm going to create a mirror image. Right, remember this thing is symmetric? So I don't know what number this is, it doesn't matter, but I would shade down, and because it's symmetric, this is also going to be 0.0038, which means my p-value is both of them together. And, well, whatever that is. I'll let you add those two things together. 0.007 something. All right, so what happens? Two-tailed test, we essentially double the p-value. All right? And that's it for today.